Welcome to HB Tuner's Ford Gen 2 Coyote Training Part 19. In this tutorial, we're going to be exploring bad injector data or bad MAF calibration. What we need to look for, what we need to check in order to make sure that we're not inputting bad injector data and or going and calibrating our MAF calibration table and absorbing bad injector data. There's a whole bunch of things we need to go and look as marker points that'll help us and guide us in making sure we don't make these mistakes and skewing up our airflow model. Without further wait, let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at being able to spot trends in our MAF calibration process, how we can validate our MAF reading and our MAF curve is correct after we've done that tuning process that I've introduced in the last tutorial. So we're going to be able to look at some trends and some data in our VCM scanner to understand if the process that we've done is accurate or not. We're going to be looking at some stock data from a Gen 1 Coyote with a stock airbox assembly. Gen 1, Gen 2, very similar. We can get an idea of what we should expect at idle and part throttle in terms of the airflow that we're seeing being ingested into the engine. So we're going to learn how we can compare the data, overlay the data, and figure out if what we've calibrated is accurate in that MAF curve. We're also going to be taking a look at wide open throttle in some data logs. On this particular vehicle, my 2017 Mustang GT that I'm using for this training course, we're going to learn if the mass airflow curve is valid at high RPM. We can very easily see if we have illogical airflow values expressed in horsepower and torque. So we're going to be introducing how to look at that in the VCM scanner with some log data. We're also going to be able to take a look at introducing the idea of looking at our injector data. Is the injector data that we're dealing with accurate or not? So if let's say we install aftermarket set of injectors. We put the injector data in supplied from the manufacturer. We fire up our engine, and what do we look for? How do we know if it's rich or lean? How do we know where the air lies? Is the air in the injector data, or is the air lying in our MAF curve? Well, there's some very easy ways to determine which is the side of the equation, so to speak, that's a problem. Remember, we have an underlying equation. Fuel mass is equal to air mass divided by target air fuel. So either the fuel mass into an injector pulse width conversion, which is all done through the injector data. Somewhere lies an error in there, so the low and high slope or the offset values are inaccurate, or our MAF curve's inaccurate. Something's wrong with the airflow that we've calibrated in the MAF curve, and we are not expressing what the airflow is going to be to the engine control module. Either we're under or over representing the airflow and therefore causing a rich or lean condition. And the short-term trims obviously will fix that, but we want to make sure the trims are doing as minimal work as possible. We want to make sure that our air and fuel model are spot on and everything is in line the way it should be. Now, as long as everything is accurate, our torque tables, our spark timing, our variable cam control, our idle, and our fuel delivery will be perfect. But if we have things wrong, we can start to introduce all kinds of errors in our torque modeling and our spark timing and our variable cam control, which will make the vehicle not run as smoothly as it should. And in some cases, it can start to run pretty erratic and just not be right. So we want to make sure we're accurate in this. That is the name of the game when we're doing our tuning and calibrating. We don't want to do things inaccurately. So this is going to allow you to spot bad data and trends. Very, very important, which is why I'm introducing this pretty early on in the training course here. So that's why I'm actually introducing this right after the MAF calibration process, because that's pretty straightforward what we've introduced in that last tutorial, looking at how to dial in the MAF curve. Very easy to take that data from the trims, the short and long-term trims, plotted into the histogram, bringing that data into the MAF curve, doing that pace special function I showed. Very easy to do that. But if you have bad data, something is causing an error somewhere, and it's not just solely responsible from let's say the MAF curve is just not calibrated. Let's say it's injectors and the MAF curve, or you've done the calibration process on the MAF curve inaccurate. Let's say you have bad O2 readings. Let's say you have an exhaust leak right before or right after the O2 readings. You can have higher oxygen content going across the O2 sensor. O2 sensor is going to report a leaner condition. That's going to cause the short-term trims to increase into a positive value. Well, you could bake that right into the MAF curve, which is going to mean that you show that you're moving more airflow at a given period output from the MAF sensor, and it'll have a snowballing effect. So it's going to say that you have more torque, and the spark timing is not going to be referenced right. You can have all kinds of problems. So how do we spot these trends? Okay, let's jump in here. I just want to go over a couple things briefly in the calibration file, and then we'll jump into our VCM scanner and start to talk about where we can pinpoint the marker points that we need to look for in our data logs. All right, so the calibration file I have open here is that MAF tuning calibration file from the last tutorial. Everything is going to be the same as what we left off with in that last tutorial. If I go here under the engine tab, and then I move here, I apologize as my laptop is moving a little bit slow. So we go here under the engine tab, and we're under airflow, and we have our MAF calibration. We know that in our MAF airflow versus period, we dial this table in so that it was having minimal trim differences when we were operating and driving the vehicle through the range. We know that this was a relatively smooth curve. This is what it should look like after we've calibrated. We want to find any low or high points. That just validates that the MAF calibration process was done properly, meaning we didn't have bad data, maybe some skewed data being plotted into the individual cell points. We jump in here to our VCM scanner. We weren't plotting arbitrary values or just skewed values into these cell points and carrying that.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.